Hello everyone, my name is Lutan. I'm here to present you our work on unsupervised multi-target domain adaptation through knowledge distillations. Currently in literature, most techniques focus on solving the problem of single target domain adaptation, STDA, meaning adapting one model to one target, despite its importance, the multi-target domain adaptation, MTDA, where we adapt one model to multiple targets, remain largely unexplored. There's currently several trivial ways to solve the MTDA problem. For example, we can have one model per target domain. However, this approach is very costly and remain impractical. The second way is to combine all the target domains together and then apply STDA on the mixture of all the target domains. However, this approach proved to have limited accuracy on multiple target domains. So for our proposed approach, we want to adapt multiple teachers on multiple different target domains and then combine their knowledge into a single common multi-target model. So the motivation for our approach is that each teacher model can be as complex as possible, which can help improve the result. The student learn compressed knowledge from the teacher instead of learning directly to generalize on several different distributions. Our method also take advantage of the state-of-the-art SEA technique since it's generic and each teacher is only adapt to one target domain. So the main idea behind our technique is illustrated in the figure 3. As you can see, each teacher is assigned a different target domain, and the teacher gradually teaches the student how to adapt to a new target domain. And a knowledge distillation technique is employed in order to transfer the domain knowledge between the teacher and the student. For the unsupervised domain adaptation for the teacher, we choose to use GraphGrad, which take advantage of the gradient reversal layer. However, any technique can be used instead of GraphGrad. As for knowledge distillation, a logic-based distillations is chosen for both target and source. For the source distillation, we just use a regular Hinton distillation, which with KL divergence loss and a supervised cross entropy loss. As for the unsupervised target distillations, we add to the KL divergence loss an additional consistency term, which encourage further domain confusion on the student itself. We also introduce the alpha hyperparameters that control the importance of the consistency term. So overall, the loss for one teacher is defined as a domain adaptation loss and also the source and the target distillation loss for the student. We introduce the beta parameters where it follows an exponential growth rate and it gradually transfers the importance of domain adaptation to knowledge distillation. Since in the beginning, the difference between the features of the student and the teacher is very small because they both start from pre-trained weights of ImageNet. To compare our method, we define several baselines. The first one is the source-only baseline, where a model is only trained on the source dataset and then evaluate on multiple target domains. The second baseline is several different STA techniques that we apply on a mixture of all target domains. The third baseline is MTDA, ETA, which is an MTDA technique that uses domain labels, and amines is another MTDA technique that assume they do not have access to the domain labels. Also, we provide the upper bound result on some of the data set in the full paper. The upper bound is model directly trained on the target domains with the class labels. So for the proposed method, in order to have a fair comparison, we introduce two versions of our method. The first one is MTDA mix, our proposed method with our domain labels. The second one is just MTDA, our proposed method with domain labels. So for the data set, we've compared them on several. First is Office Home and PACS, which we present the result in this paper, in these presentations. The other result for digits and other Office dataset are present directly on the full paper. For the comparison with MTDA, ETA on the PACS dataset, our technique performs generally most of the time better than the state-of-the-art and the baseline. The same conclusion can be done here on the Office Home dataset, where we compare with amines, MTA technique that do not use domain labels, and we perform better on both AlexNet and ResNet 50. In conclusion, a novel MTDA technique is proposed that can achieve high accuracy on multiple datasets. The technique can work with or without domain labels, and also the technique is generic and can be improved with the latest domain adaptation or knowledge distillation technique. You can find further discussion in the full paper, especially in the Adaptation study. Here's our code, and thank you for your attention.